in theory, I have all the things required to run my application. I have 2 versions of Nginx for HA. You know, that's cool. Step by step, this is how we've done applications, deployed applications forever. Not a lot of fault tolerance, coordination, limited tie-in to tangential services, right? Yeah, how do we do is a container orchestrator. And that's really what Kubernetes is, right? Docker, think of this as great for a single host, maybe for a single developer that's just trying to do a Docker run with his or her application. When we're talking production and we have a cluster of servers and we want to deploy our app in an HA fashion on those clusters, that's where we want an orchestrator. Just extra credit here. Can anybody name some of the other popular orchestrators out there? Swarm, Docker Swarm, yes. Anything else? Rancher. Mesos? What is it now? PKI? I don't know. DKI? I don't know. They renamed something obscure, but yeah, right. So folks have been thinking about orchestrators for a while. If you think of Hadoop, for example, Yarn is an orchestrator, right? These are containers. They're not Docker containers, but they are containers. There's your resource manager and your cluster, right? So folks have been thinking about ways to go ahead and distribute workloads over a server farm for maybe 10, 15 years now, right? By and large, Kubernetes has won that battle. I think we can all definitively say that at this point. So what the heck is Kubernetes, all right? Well, in a nutshell, this is what you get when you go ahead and deploy Kubernetes. You have, a control node and some worker nodes, formerly known as slave, also known as, management control plane. Most distributed systems have some central control plane that basically can coordinate with the rest of the worker nodes, right? That's principles of these types of distributed systems. So on the control node, let's talk about the 3 key components there. Actually, let's call it 4, right? So there's 4 key components. First and foremost, we need a place to kind of store the state of the application, the metadata, if you will, right? That is inserted into something called etcd. Anybody heard of etcd before? So when you think of etcd, think of database. And if you want to double click on what etcd is, think of key value pair database, right? Any other key value pair databases that folks can think of? Redis, Cassandra, HBase, okay? Who's thought about the CAP theorem? What is it, consistency? Something, I don't know, right? The database CAP theorem, right? Where databases can be 2 of the 3 things. They can either be consistent, they can be scalable, or I forgot, anyways. etcd is very unique in that it can ensure consistency when you go ahead and submit it can be distributed and consistent, okay? Which means that when you go ahead and push a key value pair into etcd, you can expect that value to be the same across the other nodes. Compare that to Cassandra, where you push a key value pair into Cassandra, and it will eventually show up in Europe, in your Cassandra cluster over there. Eventual consistency, right? So etcd has this very powerful feature, distributed and immediate consistency. Think back to Hadoop again, Zookeeper, in case anybody's heard of Zookeeper, right? Same properties as Zookeeper, okay? Question? Key value pair. So typically when you talk to database, it's SQL, it's rows and columns, right? There's a very specific class of databases where you just put a key and a value in there. And you say, push this key in, get this key out. Does that make sense? Kind of? It's a kind of a unique type of database, different than your SQL database, right? So we're not going to stick any 3 or 3rd normal form tables in etcd, right? That's not what it's for. It's really just keys and values, okay? Fortunately, that's all we need. Please.
Do anything more than just have a cluster state in there, anything else in there?
Just a cluster state, okay? So whenever you submit a request to Kubernetes, I want this many applications, I want to call it this, I want this load balancer. That all ends up in etcd, right? Cool. All right, so that's one of the key foundational pieces. There's 3 other foundational pieces that we can see here on the control plane, right? There's the API server, the controller, and the scheduler. Any guesses as to what the API server does? API calls, right? Exactly. So when you as a user are doing any sort of interactions with Kubernetes, kubectl, you guys are going to learn to love, potentially hate kubectl, that's your CLI for Kubernetes. You're talking to the API server, okay? There's something called a scheduler. What do we think the scheduler does? Schedules pods, right? Basically, the scheduler understands, deploys pods, right? Schedules pods. Basically, the scheduler understands where these pods need to get sprung up and goes ahead and asks the worker node to go ahead and do that work. There's a third component, or a fourth component there, the controller. And I think Kubernetes leverages the controller pattern throughout its architecture, right? And I think this is really one of the secret ingredient, or one of the kind of the secret sauce, if you will, of Kubernetes in terms of what the controller does, right? So let's think about what we're doing. We're going to tell Kubernetes, I want 3 instances of Nginx. Scheduler says, okay, I will schedule 3 instances of Nginx. Okay, you have 3 instances of Nginx running now in your cluster. Like this in and of itself is like not breathtaking technology, right? This is like, okay, cool, why couldn't Ansible do that for me, right? But where Kubernetes really shines is what if something happens to one of those 3 applications? Maybe the underlying VM or node dies, maybe the pod crashes, whatever. We have some state other than what we initially intended, right? So we went from 3 apps to 2 apps. Could happen, potentially, right? This is production, stuff happens, right? Somebody tripped over a cable and reset the box. I now have 2 instances when I wanted 3 instances. What does the controller do? So the controller understands what the intended state is, right? Understands that I have to have 3 versions of. And when it notices that there's only 2 instances running, it can say, hey, this is different than the intended state. Let me go ahead and talk to the scheduler to schedule a 3rd pod. And I think that's pretty neat, right? And you can think of this as just an infinite do-while loop, basically analyzing the state in Kubernetes. And if it needs to get reconciled, and if something has to happen, goes ahead and make sure that that happens, right? Now that is pretty cool tech, right? Now we've gone from just Ansible, decent orchestrator, to like, okay, this is actually pretty cool. All right, any questions? All right, cool. Let's talk about what's on the worker nodes. So there's 3 basic components. There's a kubelet. The kubelet is what the API server talks to. Okay, so the API server tells a kubelet on a worker node, hey, Mr. Kubelet, you need to spin up this pod ASAP. Kubelet goes ahead and does it. Okay. There is the container runtime. Any ideas as to what that could be? Docker, right? Any alternatives to Docker? Huh? Container IO, Container D, Cryo, Rocket, if you're an old CoreOS fan. Any old CoreOS fans? No? Okay. Cool. So anyway, there's a variety, Docker is one great container runtime, but there's other container runtimes. And then there's a third component here called kubeproxy. And kubeproxy really manages the abstraction, or let's call it the kind of the go-between your service, kind of your DNS service entries and your actual IPs for the pods. We'll get into kubeproxy in a bit, right? But that's basically it. Okay, this is Kubernetes. I think great solutions are fairly simple and elegant. I think this is definitely that, right? Any questions? Nope. All right. You guys graduated from Kubernetes 100 to 101. All right, let's keep going. So what do we actually deploy on these things? All right, so you guys are talking about containers. Kubernetes kind of takes it a step further and starts to deploy pods. Pods are basically groupings of containers, one or more containers, okay? Any ideas as to why we may not want to spin up just one container in a pod? Why we would want two containers in a pod? Any thoughts about that? Any ideas, any use cases? Huh?
Dependencies, maybe?
Dependencies? Well, you know, with a container, we're going to namespace colon bar. When we think about grouping applications within a namespace, and by the way, every application has to correspond to a namespace. There's what's called the default namespace, kind of a catch-all in case you don't specify the namespace. But in general, everything you deploy has to end up in a namespace. And namespaces are kind of useful in that they allow us to set maybe resource quotas, okay? I can say that this namespace can only use this much CPU, this much memory out of the cluster, etc. And then I can even create network policies that can do some more things, like perhaps these pods here can't talk to these pods here, right? So it's a way of grouping and even achieving some logical separation between the applications. Totally different, right? It's just a logical grouping of applications. Yep. Folks are really trying to push the envelope in terms of multi-tenant clusters. Namespace is a key component there. When I started working with Kubernetes many, many years ago, the idea was that folks were going to deploy one gigantic cluster, a la Google, within their data center, and carve that up, maybe via namespaces, network policies. That's not what people are doing nowadays. So folks have really gone to a multi-cluster approach. And I think it's gotten too far now where people are really thinking of Kubernetes clusters as almost app servers, right? One app, one Tomcat server. That's a little too much too, right? But by and large, I think there's some fine medium between maybe at a minimum a dev and a production cluster, maybe two very distinct business units, two different clusters for each one. Yeah, that's really where most folks that I talk to are actually leaning towards, right? So namespace give you some sense of grouping of applications. I would not call it a panacea for achieving multi-tenancy, but it is there. Important to know what a namespace is. Okay? Any questions? Nope, so far so good? Okay. So let's talk about some of the other concerns now.
One question regarding conflicts on hosts between namespaces. So you are putting different namespaces on potentially the same physical host, right?
Yeah, so we don't want to think of a namespace as almost like a subnet or something physical. It's just a logical grouping of applications. Right, so I can have 100 nodes, and I can have 1,000 apps belonging to maybe 1,000 namespaces, and those are all going to be interspersed, commingling, right?
Are there policies that refer to namespaces for?
Yeah, so some of the things that are namespace specific are, for example, RBAC, right? You can tie role-based access control to a namespace. You can tie what access a user has to a namespace. You can do resource quotas. You can do scoping for DNS lookups to a namespace, okay? So, yeah, you're right. There is some tying to a namespace, some ties to like policy specifically, but we don't want to think about it as like physical, right? Although you could achieve that, right? If you wanted to fence off a namespace for these 3 nodes, another namespace for these 3 nodes, remember the taints and tolerations and label selectors that I mentioned? You would use those to achieve that, but I would say that's an anti-pattern. Okay, I've seen folks try to do that, right? Where they try to have these different nodes for one namespace, another set of nodes for another namespace, and try to route everything through a firewall. Kind of old school, security domains. I don't know. I don't know about that, but I've seen people try to do that. Yes, please.
Yeah, in your previous conversation, when you had labels, right, there was a thought process behind it, get carried away. 16 label, is there best practice? Want to create a namespace that also takes like a thought process. Do you do
Totally.
geography? Do you do business unit?
100%, right? And I think it depends on a few factors. Do I have multiple clusters for my different teams? Do I have different clusters for different environments, right? If you just have one big cluster, you have a demo, maybe a namespace, a production, you could do that, right? Maybe different users with different permissions and different namespaces. Yeah, I mean, what I would do is sit down and think of all the things that I can scope to a namespace and understand how does it affect my end users, right?
Almost also build like a dictionary in that sense.
Yeah, well, yeah, and I think I would try to understand how do I make my developers' lives easy and my life easy, right? Do I really want to like micromanage my namespaces and create policies for like 100 namespaces? Maybe not. Can I get away with more coarse-grained namespaces? Do I really get really tight on the resource quotas? I mean, there's a lot of concerns there. That
Well, I agree. It's just I think it's that measure of each developer also thinks differently. But a library or dictionary, right? Then you also have that collaboration where developers are following something.
yeah. So typically, like for example, I would not allow. I don't know. That's a strong word, but personally, I would probably not allow a developer to create a namespace. As an admin, I would create this sandbox within the cluster, a namespace, give the developer the permissions he or she can use, and then let them go at it, right? That's kind of the way I would think about it. Yeah, good questions. But these are all things that are very specific to your shop and things that you would have to think about for sure. And the things that are often overlooked, right? It's like, oh, great, I got Kubernetes up and running. What about day 2, day 3 ops, right? Those are largely more important than just getting it up and running. Okay, great questions. Any other questions? No, so far so good. No, go ahead.
Where does the namespace live? Is it part of the key pair table?
It's netcd. Yep. All of this, right? Labels, the IP to container mapping, all of that stuff is in netcd. Okay, good questions. Any other questions? Yeah. Bridge networking. All right, we're going to get to networking. We'll get there, I promise. Okay, because you guys did see the Docker talk on how containers talk over a bridge, you can forget about that. All right, Kubernetes does it a lot differently. Okay? Kubernetes just handles that problem much, much differently. Okay? Is very opinionated about a lot of things, but it has not a lot of opinions around maybe 2 key things, and that's the networking stack and the storage. Right? There's a container network interface, there's a container storage interface, and as long as you bring the networking that matches up to the container networking interface, aka the CNI, you're good to go. Kubernetes doesn't care so much, right? Same thing with the storage. Turns out these are 2 kind of difficult problems to solve, right? As a Kubernetes person, am I going to use classical? Am I on PKS? I'm going to use NSX. These are like first things you have to do. The other one is storage. Invariably, you're going to have some application. Not everything can be stateless, right? It'd be great if everything was stateless, but it's not. So some things are going to have state. How do I actually manage that data in my cluster, right? So with Kubernetes, we do have the abstractions there, right? So if I create a pod, be an application and a database. If something were to go ahead and happen to that application on worker node 1, the scheduler or the controller figures out that something happened to this guy, tries to schedule it on the second worker node. Guess what? Do you see the database data? Goes to empty database data, right? Probably not what we want, right? We don't want to lose login information, user IDs, all of that. So how do we go ahead and make sure that that doesn't happen? Well, we can put our data in cluster storage and basically allow that storage to follow the pod wherever it may be, right? So something could be like NFS, potentially. Could be, if you're on Amazon, could be an EBS volume, right? That just gets plugged into the pod and can follow that pod across the AZ. Could be something like a Ceph or a Gluster, right? These distributed storage engines. There's a whole host of open source solutions. There's, Rook.io. There's, there's Portworx is kind of a paid solution. I think it runs on Ceph. But there's a lot of different solutions. Some are open source, some are paid for. VMware, I think, does actually a very good job with storage. Maybe somebody has a different opinion, but I think by and large they've solved how to do distributed storage. So when you're running Kubernetes on VMware, I think it makes that problem like trivially simple to solve, right? Which is kind of nice, right? Unless you want to run your own Ceph and Gluster and put up with 2 a.m. calls that, hey, database is down. You may want to look at something like a VMware or a Portworx or somebody that does it in an enterprise fashion. Okay? Any questions around that? All right, so storage, one of the things you guys are going to have to figure out, for sure. Not something Kubernetes does for you. All right, so I think this slide is a little out of place because now we're talking about deployments. But we'll get back to it. Right? So again, deployment, there's some metadata. At the end of the day, you want 3 replicas of the application, so you get 3 instances of Nginx. I'll rearrange that slide so it's where it should be. Let's talk about networking a bit here. So we're going to talk, so networking in Kubernetes has some basic concerns, right? How do we give an IP to a pod? How do we go ahead and create a service that fronts my pod so that other applications talk to the service and also not try to keep track of the floating IP? These are some of the basic things that we need our networking stack to go ahead and solve for us, okay? So when we go ahead and think about this, when we think about a Kubernetes service, which is kind of an object in Kubernetes, and I think this is really also one of the things that makes, we talk about secret sauce. I think the service to pod mapping is one of them, right? So again, we deploy our pods. They're all given ephemeral dynamic IPs, right? So you cannot trust that 172.14.6.2 is always going to be assigned to that application. But guess what? We can use labels, right? And we can apply a label to that pod. And what we can do is create a service that says, go ahead and load balance between any pod that has the label app equals planespotter-fe. Pretty neat, right? Easy as that. No longer have to go ahead and figure out what nodes these apps are. Don't care what IP this is on. This, you don't have to tell it what node it's on. You don't have to tell it what IPs are associated. It's like magic. It works. Not quite magic. Remember kubeproxy that I mentioned early on? kubeproxy, one of the 3 components on the worker nodes. kubeproxy plays an important role in mapping this service to the actual nodes that have the actual pods running on them. Any questions? No? Super easy, right? Pretty awesome. Okay, cool. So this is for communication within cluster, right? This is service to service within the cluster. Some apps actually need to be exposed to the world, right? I mean, some of these are internet-facing applications. How do we actually expose these services out to the world? So there's 3 basic paradigms. When you expose a service, you can do what's called a node port. You can do a load balancer, or you can have an ingress controller. Okay. Foods here. So we'll just briefly know that there's these 3. We're going to briefly touch on all 3. I won't dive too much detail. Feel free to ask me during lunch. Okay. So the first one is the node ports. Basically, what we're going to do is expose a port on every single node in the cluster out of some random block of ports. And if you hit the host on that port, on any host, it'll arrive that it's intended to. Not ideal. If you're using one port on every block, If you're on Amazon, if you're on VMware, you're using NSXT, you can actually spin up a load balancer. Okay, that's a little more prescriptive in terms of where it directs traffic to. Okay, and if a third option is an ingress, right? So there's something called a hot proxy or an Nginx ingress, and you could do some things like you do path-based forwarding, etc., with the ingress. You do SSL termination. Man, we could talk for hours on services, right? But suffice it to say, 3 basic patterns: node port, ingress, and load balancer. Okay. Networking with NSXT. This is Vmware after all. You know, pretty awesome. Just like VMware, I think, has solved the storage problem that we're going to have with Kubernetes. It's also solving kind of the exposing of my services to the world by actually creating software-based load balancers for me, right? So you really get that AWS look and feel on VMware, which is pretty cool, okay? I can just create a service of type load balancer. I get a routable IP. Voila, I'm done, okay? So I talked about kubectl earlier. kubectl is what you guys are going to be doing throughout the lab. You guys are going to get to know it very well. You're basically going to use it to interact with the cluster to get the deployments, get my pods, describe, get events, deploy, delete. You're going to do all of that via kubectl. Okay? So let's talk about some of the deployment descriptors. This is a service, right? Let's ask some questions here, right? So I'm deploying a service in Kubernetes. This is called YAML. I think it stands for yet another markup language, right? Think of JSON, XML before it. Who knows if I'll be alive for the next one, but something's going to come up eventually to replace YAML. But let's think about how this service is actually constructed. What port are we going to push requests to on a container? What port, based on that descriptor? 80, okay. What applications am I going to push traffic to on port 80? Nginx, but how do I, where's my, like, how do I know it's Nginx? Okay, it's Nginx. This app Nginx, is that a label? What is that? Huh? Oh, quite. Is it a label? Is it a container image? Let's think about this. I can have multiple Nginxes hosting different applications in my cluster. Labels, right? We're going to think of applications in terms of labels. So remember what I said earlier, how we can create a service and it's going to route traffic to any pod that has a specific label? The selector is where the label actually lives. Okay? Questions around that? No? Okay. So in order So we now have a service that's going to load balance across port 80 to any application that has the app equals Nginx. Okay? All right. So this is the deployment. How many instances of this Nginx do we need? 3. Perfect. What port are we going to expose on the container? 80. Okay. What version of Nginx are we going to use? 179. What labels are we going to deployment? App equals Nginx. Exactly. Right? So now we can see how the service is looking for any deployment that has label app equals Nginx. We can see that my deployment fits that description. So guess what? Once this gets deployed, I can actually ping that. Pretty easy. I mean, I think that's pretty easy, right, in terms of what you get out of it. A service fronting 3 distinct applications, load balancing between them, no notion of an IP. I mean, pretty easy as it can get, right? Cool. Let's talk about network policies next, Okay, so we do want to have some sort of firewalling capability in terms of who can talk to who. Kubernetes does have some basic network policies. So for example, here is a label that says MySQL deny all, right? Again, we're going to look for any application that has a label tier equals MySQL, and we're not going to allow traffic from anything. Remember, the square brackets are empty here. Okay, so this basically is going to look for any pod that has tier equals MySQL as a label, and it's going to go ahead and cut off any sort of communication to that pod. Probably not what we want, right? Somebody actually has to talk to this thing, right? So you could go ahead and create another policy that says ingress from maybe another application, another label, right? App equals middle tier, app equals whatever, and you can allow that specific application with those labels to talk to this database. Okay? So putting it all together here, last slide, folks. Basically, when we think of cloud native apps, oh, please go ahead.
Real quick about the section where you can do kind of priority, so you can, how the
Yeah.
needs to be conflicting or what overrides.
Yeah, so network policies are pretty basic, man. All we can do is really, I think it's just, we could just allow traffic from specific pods. We cannot do any forceful denies. So because we do not have any sort of forceful denies, network policies do not really need a sense of ordering. If you think about Calico, where you can have allow and deny clauses, that's where ordering comes into the picture. Does that make sense? So take a look at Calico if you want to get really fine-grained with these policies, and you'll definitely have, ordering is important when you can do denies. Okay, this just does allows from specifics. Doesn't matter so much, okay? How it's evaluated.
So
Great question.
It matters which CNI you're using.
Matters which, 100%, 100%, right? So you will get network policies with just about any CNI, whether it's Flannel, Calico, Weaveworks, NSX, you'll get network policy. But if you really want to get like really hardcore, super fine-grained policies, take a look at Calico. Okay? Because you can get really aggressive in terms of who can talk to who. Go ahead. Calico, Project Calico. I think I came from Tigera, so I near my heart. Okay, cool. Great questions. Any other questions? Is everybody hungry? Okay, cool. So we're done, guys. So lab. I think it's also time for food. Maybe food and lab. Yeah, and I'm here, so feel free to. Raghu and I are both here, so feel free to ask us any questions.